Now we move on to example 3. Given x plus 1 is one of the roots of the polynomial of px. So for question A, find the value of m using remainder theorem. So second second question, find the quotient and remainder of px using long division. Finally, hence factorize px completely. So since x, so since x plus 1 is one of the roots of the polynomial of px. So as we learned before, if x plus 1 is the root, the remainder, let's change to red color, let's say here. So the remainder suppose is equals to 0, which means that if I substitute this value x plus 1, which is equals to x is equals to minus 1, so p, if I substitute into this function p negative 1, suppose the output will be equals to 0. Why? Because x plus 1 is one of the roots. So now we look at the solution. So question A. So I let x plus 1 is equals to 0. So x will be equals to negative 1. In next step, I will substitute into the function of p. So p negative 1. So when I substitute into this function, which is 6 times negative 1 power of 3 plus m times negative 1 squared minus 3 times negative 1 minus 2, suppose will be equals to 0. Why? Because x is equals to negative 1 is one of the roots. So this one suppose will be equals to 0. So now I try to simplify this expression. So negative 6 times negative 1 power of 3 is negative 1 plus m, negative 1 power of 2 is positive 1, negative 3 times negative 1 is positive 3, minus 2 is equals to 0. So 6 times negative 1, negative 6 plus m plus 3 minus 2 is equals to 0. So here is m, negative 6 plus 3, negative 3 minus 2, negative 5 is equals to 0. So m will be equals to 5. So this is the answer for A. So where our m is equals to 5. So here, okay. Now we move on to question B. Find the quotient and remainder. Of course, in this question, our remainder will equals to 0. So remainder of px using long division. Next, by using long division, 6x cubed plus mx squared. Oh no, sorry. So we already found our value of m. So our m is 5. So means that 5x squared minus 3x minus 2 divided by x plus 1. So in order to get 6x cubed, again, so here we have to consider here, in order to get 6x cubed from x, so I have to multiply by 6x squared. So x times 6x squared, 6x cubed, 1 times 6x squared, positive 6x squared. So over, so here is minus, cancel out the first term, 5x minus 6x squared. So 5 minus 6 will become negative x squared. Bring this negative 3x. So next, you can see, in order to get negative x squared from x, so I have to multiply with negative x. So x times negative x squared. 1 times negative x, negative x. So here is over and then minus. We can cancel out the first term. negative 3x squared minus negative x. So negative is positive. Negative 3x plus x, negative 2x minus 2. So finally, in order to get negative 2x, so I have to multiply with negative 2. So x times negative 2, negative 2x. 1 times negative 2, negative 2. From here, you can see that our remainder for sure is 0. So here I can write quotient is equals to 6x squared minus x minus 2, and the quotient, and the remainder will be equals to 0. So now we come to question C. Factorize px completely. So if you still remember, let's say this part. So fx can be formed by dx multiplied by quotient plus the remainder. So we are using this one to factorize the function completely. So now we come back here. So px can be formed by multiply the divisor with quotient plus the remainder. So where our divisor, in this case our divisor is x plus 1. So x plus 1 plus the quotient. So our quotient is, so here is our quotient, 6x squared minus x minus 2, 6x squared minus x minus 2, plus the remainder is 0. So from here, we concentrate on this part, we can factorize in this part. So finally, this x plus 1. So I try to factorize. Here is 3x. Let's say here is 2x. So from here, negative x. So suppose here is negative 2 plus 1. So you can use your calculator in order to factorize for this one. So here, let's say I try to check 3x squared times 2x, 6x squared, negative 2 times 1, negative 2, negative 4 plus 3, negative x. So this is the answer. Factorize px completely. So now I have factorized the px completely.